Bright QT. Every student matters.
Compounds of carbon. Now, carbon forms compounds with hydrogen. It can form compounds with oxygen. It can form compounds with nitrogen, sometimes even sulfur. So, why is it that carbon can combine with so many things? And why is it that carbon is there in so many different forms around us? What makes it so special? What is that property which leads to carbon having so many compounds? The reason for that is the first is catenation. So catenation is the property by which an atom combines with different atoms of its kind and forms long chains like this. So carbon can go on combining and form a very long chain with its own atoms, and this is not present in all other elements. That is majorly because of the big size, elements cannot hold such long chains, but carbon has this property with which it can hold a very, very long chain effectively. Other elements only can hold maximum 7 or 8 elements, like silicon or sulfur can hold up to 7 to 8 atoms chain, but carbon can go on forming very long chains. These chains can also be different. The chain can be branched like this. The chain can be cyclic like this, and it can also exist in the simple form like this. So it can be branched, it can be cyclic, and it can be a plain long chain. It can also have double bonds in between. It can have triple bonds, and that is why it is possible for carbon to form so many compounds. So that is the first reason, catenation, which is the property of an element to form long chains by forming covalent bonds with itself. Right. The second property that gives carbon this special feature is tetravalency. Now, carbon has a valency of 4, which means carbon can attach to 4 monovalent items. By monovalent, I mean elements which have valency of 1. So, it can attach to hydrogen, right? It can attach to diatomic elements, which that means things with valency 2. So, for example, here's a carbon which has hydrogen on 2 sides. It can form a double bond with oxygen. It can also form a triple bond with elements which have a valency of 3. So because of the tetravalency, it has a lot of opportunities to combine with monovalent, to combine with divalent, and to combine with trivalent elements. And because of catenation and because of tetravalency, these are the two special properties. So if they ask you in exam that what is the property because of which carbon has so many compounds around us, or what is the reason for carbon existing in such wide variety of things around us, the reason are two. One is its property of catenation, another is the property of tetravalency. Both of these occur specifically in carbon because of its small size. Bigger elements also have tetravalency and catenation, but because their size is so huge, they cannot hold these bonds. So carbon is a small element, right? So when it has to form a bond with nitrogen, for example, there's a strong energy force between them. But when the atom grows bigger, the proton cannot exert very strong force, and that is why bigger atoms cannot form as many compounds as carbon can. So because of the size, catenation and tetravalency are the features which give it this special criteria, right? Now we discussed this before, that what are organic compounds. So why is the study of carbon called as organic chemistry? So initially it so happened that everybody was very sure that anything which is related to carbon will exist in the nature. So it was taken for granted that carbon compounds cannot be created, rather carbon compounds can only be derived from living sources. And that is why the name organic chemistry, that is why the study of chemistry, the study of the compounds of carbon is still called organic chemistry. This is because carbon's compounds were thought to be derived only from living organisms. Even then, it had 3 exceptions. It had the exception of oxides. So oxides of carbon dioxide were not considered part of organic nature. Then there were carbonates, which existed in nature like marbles, and bicarbonates, also called as hydrogen carbonate. Right? So these 3 things, with the exception of these 3 forms of carbon, it was believed that everything exists only in form of living organisms and can only be derived from them and cannot be created on its own. But later, in an experiment, ammonia was created and so forth. Many other elements have been created in labs, And it is not true now that carbon compounds can only be found in living organisms, but still the study is often called as organic chemistry. Right, so this was a short note which is based on the yellow box that is there in the chapters. Now let's move on to the most important forms of carbon compounds, which are hydrocarbons. Hydrocarbons, as the name suggests, very simply is a compound which has only hydrogen and only carbon. So a compound made of carbon and hydrogen only is called as hydrocarbon, right? These are one of the few compounds of carbon that we'll be talking about. They are the basic forms. So if you understand this better, you'll be able to understand the entire chapter that continues later better, in a better way, right? So hydrocarbons are compounds which have carbon and hydrogen only. They can be arranged in multiple ways. The most simplest would be this, which we discussed before also, methane. Other forms can have longer chains, where all the valencies are filled by hydrogen. Right? So here, since there are four, it will be called butane. Why is it called that? We'll understand that later. And it can also have double bonds with itself, it can have a triple bond with itself, and fill the remaining valencies with hydrogen. In all of these cases, they're all still called hydrocarbons because there's no third element involved. As long as there's only carbon and hydrogen, no matter if it's double bond, triple bond, or a single bond, it is still called a hydrocarbon, right?